Welcome everyone to my talk about what containers can do to improve your development experience. Ever since the arrival of Docker with its popular container solution, I'm a fan. I'm a big fan. I had the impression that this would become something important. Yeah, I noticed the added value to deploy applications, but I also noticed the added value for me and my fellow software engineers during their development time. This session will take about 30 minutes, which includes slides and explanations, but also some demos. It might help to have some container knowledge, but it's not a necessity. I expect you will understand what I'm talking about, even without that knowledge. Also, there will be enough time to ask questions at the end of this session. My name is Vincent Hendriks. I've been a software engineer for over 16 years, not counting my pre-professional time developing, which would make it over 26 years. Hobby time doesn't count, right? I've mostly worked with Microsoft-related development, but also things like containers and Kubernetes are topics I enjoy very much. Even though I've been doing this for a very long time, it never gets bored. This is why I started it, I guess. I also love to share my knowledge with anyone who's willing to listen, which is why I'm doing this session. I currently work for Team Rockstar's IT and have an assignment for a cryptocurrency broker called Anycoin Direct. If you ever have some questions regarding Bitcoin, there's a good chance I can and want to tell you things about that as well, as long as it's not about the price, what it will be, etc. Honestly, I don't know. Containers. Container technology exists for years, even way before Docker made it easier. Thanks to Docker, it's become very, very popular the last couple of years. It has brought the option to easily package and deploy applications with the slogan, build, ship, run, any app, anywhere. It's much more lightweight compared to virtual machines. That doesn't mean virtual machines are obsolete. On the contrary, they're used together. Virtual machines are, for example, used for a Kubernetes node, and on top of that, we're running containers. Containers have done a great deal for our entire DTAP stream, or at least it has done a great deal for our testing, acceptance, and production environment. But for development environments, often it is or was even so that containers used to be relevant after development. Applications would be developed locally, and when they're ready, they would be packaged in a Docker container and run through our test, acceptance, and production environments. It allowed us to run multiple applications in a somewhat isolated way on one or more machines. Even though this already brought great improvements, something is still missing from my point of view. We can do so much better. I still need developer tools like Node.js, NPM, several SDKs, a local SQL server, an SMTP server, you name it. And these tools and services should also be updated on a regular basis, right? Preferably on the same version as our production environment, or else we get the saying, works on my machine a bit more often. And then I've not even touched the topic of documentation. Yeah, I know a lot of people don't like writing and updating documentation. I'm actually one of them. I'm talking about the documentation of your dev environment, which tools to install, what services, etc. It's always outdated, right? Assuming you have documentation about that part at least. Also, when you take a good look around you, a lot of teams are still working with products and code bases which existed for quite some time and don't even run in containers. Don't worry, I'm not judging, I understand. I, as a software engineer, understand things like that exist and are perfectly normal. But does that mean containers are of no value? One of the first things I do when I get to work on a solution without any container support is to start adding a Docker Compose with all the relevant supporting services like logging, an SMTP server, a SQL database, you name it. I've done this a couple of times without even adding Docker support to the app itself. And every time I've made the entire team happier. Why would I do this? Well, first of all, I don't want to install specific services on my machine. It breaks other solutions and messes up my system. Also, if I need to switch between specific versions, either newer or older, this is done very easily if it's just a Docker container. But it also shows other devs that the added value of containers, which is pretty normal with new technology. Not everyone instantly sees the value of something and can be reluctant to use it until they themselves see the value. I'm also a big fan of small iterative steps in the right direction. I'm convinced that when people are starting to see value, this means they themselves will start using things like this. So basically what I'm saying is, if you're in a situation like this, start adding a basic Docker Compose for your additional services. What I've just said is only just about containers you also use for your development, right? This has advantages, but is it perfect? No. A typical dev environment has more than just these services. Think about SDKs, compilers, debuggers, code generators, you name it. Actually, you don't want to manage, update, fix all these tools all the time, and you just want to develop, preferably in an instant ready-to-use IDE locally or even in the cloud. I just want to develop. But why can't you just run your entire dev environment in the cloud or in a container? This is possible nowadays. When we can create containers for production runtimes, why can't we also just install our SDKs tools inside a container? An instant dev environment in a matter of minutes. And you know what? You can even share them with your entire team. A new team member also doesn't have to go through any manual steps in creating a new dev environment and can start adding value much quicker. It's all about just having a Docker file or an existing Docker image. I think everyone who has ever worked with containers knows how easy it is to spin up a container, right? Now, imagine that that container is your dev environment. A while back, I wanted to learn some new skills about Python and machine learning. I blocked the entire day, made sure I had a good working place where I couldn't be disturbed and where I could focus 100%. You know how that turned out? It took me the half of the day trying to set up my environment correctly. That was a pretty painful situation as I wasted my time when I just wanted to learn new things. If I knew then what I knew now, that wouldn't have happened. We have great tools we can use to instantly create ready-to-use development environments. With a containerized dev environment, you can easily start a new environment, stop it, restart it, but also simply switch between versions of SDKs or any services I've installed inside that container. You can even have a different image per code base or product, for example. This is not something you can do so easily with a VM. Imagine you have microservices. Do you want one development environment for all of them? But now I can hear people who have some more experience with containers thinking, that's all great having those SDKs in a Docker image, but how would I develop using that container then? I don't have a UI. Well, we could use a text-based IDE like the old days, SSH into that container and go. Ideal? No. By the way, I actually developed in an IDE like this. You're probably thinking he's that old. No, I just started very early. The variant I've worked with most of the time so far is VS Code. Like most of you might know, is that it's pretty nice. It's pretty nice text editor, but this text editor is built in a special way. It was built as an Electron app. Who doesn't know what that is? It's a tool used to build desktop apps using web tech. VS Code was actually built using two parts, client side and server side. Now you might think, where are you going with this? What's the point? Well, if you take that server side of VS Code and put that part inside a Docker container and the client side outside of the container, well, now you have a containerized dev environment running on your local machine. Containers aren't the only option you have when using VS Code, though. You can connect VS Code like to an SSH server where it installs the server side through that SSH terminal. But it also through WSL2. It's also an option. Then there is the local containers and code spaces. Code spaces is something I will touch in a bit again, but for now I'm focusing on the local container variant because, well, this session is all about containers. But how does this work? Well, let me show you. Let us create one from scratch. What I have here is a basic VS Code setup. There's actually one important extension you need to install, which is the VS Code remote extension pack. You can easily just install it from the marketplace. Apart from that, you need Docker, of course. Now let's start one. I got here a blank folder, basically just a little markdown file, but apart from that, there's nothing. And when you have the remote extension pack installed, you can just easily go through a wizard, which helps you set up your dev container. There are a lot of predefined dev container setups like templates, which you can install. Pretty much everything you might need is already there. And if it's not, you can always develop your own setup. Let me pick one. Is it? So, few things you may choose. For example, do you want Node.js installed? Yes or no? Do you want Azure CLI installed? This is something per template, which the options you get. In this case, I don't want any additional option. I just want basic dev container. One of the most important files you will have is like the dev container.json. And it's basically a description of how your dev container should look like. In this case, how should it build your Docker image? In this case, it's just pointing to a Docker file and has some arguments, but it could also be reference to a pre-built Docker image as well. Which extensions should you install? But also like which user it should run as. Let me take a look at the Docker file. In this case, it's a pretty basic one because it's just using a base image from Microsoft, but you can also do this from scratch using an Ubuntu base image, for example. Once you have this, it's all a matter of just running it inside a container. It will now restart VS Code. It will build the Docker image, after which it will run the container and then install the VS Code server part inside that container. This might take a little while, especially the first time. In this case, it's almost ready. When it's connected, you will see on the left side corner, it's connected like this. And now we have VS Code's client side running on my Windows machine, but the server side part is inside a Linux container. I can even start a new terminal, a bash terminal, like so. And I can even create a new project. In this case, I'm using .NET, but this works for any environment basically, as long as you can build the SDKs and things like that inside your container. No. It's also installing a package right now, which is OmniSharp, which you need for C# development, basically. You can also debug if you want, things like that. This also takes a little while for the first time. But I can already run it, for example. And because you're using VS Code, you can also use like shortcuts for building, for running, debugging, of course. That's basically already it. It's that easy. But you've seen a little bit on how this works now, but there are actually two main variants possible. You have the single container development environments and the multi-container development environments. Single container development environments, well, yeah, the concept is pretty straightforward, and it's just like the title says. It's just one container with everything you need inside, the SDKs, the tools, the database server. Advantage is that you can easily access everything from a terminal inside VS Code. Perhaps you want to use some kind of CLI, which was included. Disadvantages are that you now have one big Docker file, for example, and less reuse, unless you want to copy paste, but I highly doubt that. That's why dry is considered important, right? But what I mean is the following. Imagine you have a service like RabbitMQ, for example. I can easily install this inside your container, but what if there is a new release of RabbitMQ? Then you need to update the install script inside your existing Docker file, etc. But there are already pre-built Docker images for RabbitMQ, which you could have just run beside your current dev container. Basically, use a single dev container typically when it's about one service, which you want pretty close by in terms of access using terminal or the CLI. Now about multi-container dev environments. The name gives away a lot as well. This setup is about having multiple containers running. You can use custom-built Docker images through multiple Docker files or using pre-built Docker images. One of the advantages here is that it's easier to update one of those separate containers without impacting your dev container. But there are also additional security advantages. Imagine you're using a service and you install this inside the same container where your source code is. We all know every service or tool or SDK we use is 100% safe, right? For whoever's thinking that is the case, I'm sorry to disappoint you, it's not. When you run a separate container, then this container cannot access your source code by default. Which helps. A disadvantage here is that it's not that easy to access that service yourself. You could open up a terminal into that container, but it's a little bit more cumbersome. Anyhow, let me show you how this works. I already have different VS Code running. And let me open up the existing setup I have, and here you see still a dev container JSON file. It's a little bit cleaned up, but in the basics it's the same. But there's one major difference. Before I had like a JSON block which pointed to a Docker file. In this case, I'm pointing to a Docker Compose file. And this Docker Compose file specifies all the containers I want to run as part of my development environment. For example, if I'm developing against a SQL Server, then I want to have SQL Server running. Seek is just a logging server, and here we have the same setup for our VS Code part, which has the source code and can compile. Let me open this one. It's starting. In case you don't have those Docker images on your machine, it will basically download it, which could take a little bit as well. But in this case, that I already have that running. It's almost there. I can open up a different terminal just to show you what is running right now. You see the Seek, VS Code, and SQL Server running. And also here I can build it. Right. But let me also you'll see that OmniSharp, which is running, isn't seeing all the types and namespaces. It doesn't understand it. That's a little bug of OmniSharp, but hopefully that'll get fixed soon. Let me run this, put a breakpoint on it as well. And here you have it. You are debugging inside a Docker container while your basically VS Code client still running on your Windows desktop, basically. All right. Container scanning. An important but sometimes forgotten subject, which can lead to painful situations. Everybody here has done an npm install or an apt-get install. Hey, you can install tools on dependencies super fast. And without all these third-party tools, I would be building my software a lot slower. But there is one issue here. Trust. You are trusting that it's safe, that the publisher can be trusted. But is that the case? How does the publisher secure its pipeline, which publishes to the registry? Is that publisher using security scanning tools themselves to check their software and its dependencies? But also, do you have the correct package? Or did you possibly make a typo? Or did the person who wrote the blog you've been reading made a mistake? Possibly on purpose, I don't know. We typically scan our dev machines with the use of a virus scanner or something similar, but they're never going to find everything. Are they even built to find malware like this? Nowadays, there are great tools to scan Docker images which are meant specifically for this purpose. You can use these tools to scan your application image, but aren't you already too late? why not use these tools to scan your dev environment as well? Now that is also an option. Your source code is pretty high value. You don't want to lose that. There are tools you've seen slide: Anchor, Claire, Aqua, Qualis, and I'm not sure how to pronounce Snake, I don't know. Qualis, if I'm not mistaken, is even part of the Azure container registry, and Snake or Snake, it's part of the Docker Hub basically already. And you can even use the Docker scan CLI command. Let me show you as well a little bit about this part. This is a dev container for a Flutter dev environment, or at least the image part of it. It installs the Android SDK and Flutter and everything. And when you publish this to the Docker Hub, it can provide scanning functionality, and you get a whole overview of what might be wrong in your Docker image. In this case, there aren't any high vulnerabilities, but what you get is like advice on how to fix it, on which version it's fixed, things like that you can decide on whether or not to fix this. Cloud-based development environments. Now you've seen containerized dev environments, and in my opinion, this already offers a lot. Standardization of your dev environment, additional isolation, security scanning. I consider these things game changers already. But what if you wanted more security? It's 2021, and most of us have been working from home for over a year, right? Laptops taken home, plugged into the home network. I can see some risks here. This is not something new, of course. A lot of developers simply use a laptop and want to be able to work from home. But that usually means that they also take their source code. There are also developers who work on a VM in the cloud, but experience tells that isn't ideal as well. It doesn't grant the same advantages compared to a containerized development environment where things are isolated at a much smaller way. Typically, it's one VM with multiple code bases from multiple products. Also, maintaining or updating in a VM is also a bit more cumbersome, although not impossible. But what if? What if you could take that nice containerized dev environment I showed to you earlier and just run it in the cloud? To do that, there are services like GitHub Codespaces which can do exactly that. GitHub Codespaces was formerly known as Visual Studio Codespaces, and if I'm not mistaken, Visual Studio Online as well. What GitHub Codespaces does is that they spin up machines defined by a dev container file we saw earlier, installs the VS Code server side part, and lets you develop using the VS Code frontend in a browser. One side note, when I'm talking about that the dev container file, that's for Linux-based dev environments only. VS Code, for example, doesn't support Windows containers yet. GitHub Codespaces does offer Windows-based environments, but it does that through Windows VMs. GitHub Codespaces is in preview, but I am going to show you a little bit. Here I have a GitHub repository. It's just a simple MVC project. And here you see a familiar code button. And when you click that, you get a list of codespaces which you can connect to. This one was created earlier as well by me. And I can just continue this dev session. Now it's spinning up the VM. and installing the containers just like a local VS Code setup. GitHub Codespaces, you can use it from the browser, but you can also use a local VS Code instance, and they're also working on support for Visual Studio itself. So not VS Code, but actual Visual Studio. Visual Studio is a lot better for .NET development. It's you're probably also more used to that kind of development if you're a .NET developer. So that would be nice. Now I have the VS Code browser version. I have a terminal just like before. I can build it. I can even commit to Git from here. It's already pre-configured. Let me run this. But now you'll be thinking like, okay, this is building, compiling, and running on somebody else's machine. But how do I access my my website then? I have to access it. This isn't a public website, right? Or it shouldn't be. What you get here is few links. These ports are forwarded to this address. When I open that link, I see the project I am running from my code space. I can debug, I can change the code, of course, and I can commit just like having a local VS Code. We're reaching the end of my session. Hopefully the possibilities are clear and you can see the power of containerized dev environments. Clean, always documented environments, it's source controlled, can be peer reviewed. Think about what this could do for training, where people get a pre-built environment and no one will be struggling to get things up and running. Also think about the next time you need to do some tests for your new job or when you need to show some code. You can possibly think of some more scenarios yourself, but also think about the added security advantages you get, which is a must nowadays and isn't a luxury. I think containers are making my dev experience better, more efficient, and safer. I hope you enjoyed this session and that you've learned something new. I enjoyed talking about this topic and sharing my knowledge. There is time for asking questions, but I also have one question for you. Would you like to give me some feedback on this session in order for me to improve this talk? It's a very basic form, doesn't require any personal information to fill in, and I would appreciate it very much. But apart from that, are there any questions?